So, hi, my name is Gilles Fedak. I'm CEO co-founder of iExec. This talk will be presented also with Hadrien Croubois, who is a research engineer at iExec, in charge with everything related to blockchain development, smart contract security, and everything. So this talk today is about the thing you can develop using iExec and using confidential computing. So maybe you are aware of this new trend in the IT industry, which is called, it could be called confidential computed or trusted compute, or it can have the name of the technologies, just trusted execution environment, T. So if you are aware of that, what we want to explain and give some examples today is what you can do by combining blockchain, decentralization, and confidential computing. And I hope you will be excited about those new perspectives. We are very happy to provide probably one of the first environment that allows you to develop such kind of applications. So the outline of the talk is the following. I will give you first a short intro to iExec. I will briefly introduce you to trusted compute and confidential computing. Then Hadrien is going to present you how those things work with iExec, how you can use the SDK to build applications that combine those two things. I will give you some use cases. I hope this will allows you to understand and get an idea of the possibility of those two technologies. Then we'll briefly conclude and gives you the bounties that are open for this hackathon this weekend. So at iExec, we are building a decentralized marketplace for computing resources. So what does it mean? Think it as a sort of open network that everyone can join, where you can monetize your applications, your servers, or your data sets. So this is a decentralized marketplace in the sense that there is no central authority. So providers and requesters make deals in a peer-to-peer way. And of course, iExec, we are not a middleman in those deals. And we build all the technology and the consensus protocols around that to make sure that once a deal is sealed, there is a consensus, and how the computing resources are being used are actually related to the deal that was done. And then of course, using the blockchain, everything is then automated, payments, staking, everything, the consensus protocol, etc. So to give you a brief overview of the project, we started thinking about iExec in 2016. We did our white paper and ICO at early 2017, and since then we have been developing the platform. We released 4 versions of iExec, and each version gives additional features. So we started by allowing people to do off-chain computing back in 2017. Then we developed the marketplace. We are probably one of the first platforms that allows you to rent your data while keeping ownership of the data. That's something really important. We also provided an SDK for doing off-chain computing using trusted execution environment. That's probably one of the first of that kind. And the last version that was released back in December last year allows you to create what we call bag of tasks. So bag of tasks allows developer to execute parallel applications on the iExec decentralized cloud. We support GPU. We have a sidechain that allows you avoids to pay high transaction fees when using the platform. So this thing is running. It's there. You can use it as a developer. You can build your applications on top of that. So the trust model for iExec is the following. So what you first have to consider is that the grain of execution is a task. So basically, as a requester, you will ask iExec to execute for you a task. And iExec, actually, that's a set of providers. So for each task executed, you may have providers that gives the application, that gives the server, or the data. And each time a task is executed, those providers are rewarded, are paid for executing this task. So the way it works is that we emit orders in a decentralized marketplace. When orders matches, requester orders or provider orders match, we seal the deal in the blockchain, and then there is a consensus protocol that we developed, which is called proof of contribution, that basically verify that the deal has been fulfilled by all the stakeholders. And when this actually happens, when we can verify this, the requester get the result and the providers get the payments. So one thing that is super important in conjunction with this, as you can understand, is the technology called Trusted Execution Environment. So maybe you are aware of that. One of the commercial names, for instance, for this particular technology is Intel SGX, ARM Trust Zone, or AMD has its own version too called SEV, which is being released right now, I think. So we call that a hardware enclave. So what's that? This is basically a feature in your processors which allows to have a segment of the memory that is fully encrypted. And we call that an enclave. So every execution that will happen within this enclave will be fully protected. It means that if you run an application within an enclave, you can provide, all the encrypted data are never decrypted, and even the administrator of the machine does not have access to what happens within the enclave. Okay, so that's very important because the scope of decentralization, this allows you to execute any application using any kind of data on any remote machine, and you are sure that the execution cannot be tampered, cannot be modified, that the secrets are never revealed. So as you understand, there's a very, there are really huge perspective for that. It's a real breakthrough. So we have several activities around T and blockchain computing. We are participating to the Enterprise Ethereum Alliance, and we co-develop with Intel the off-chain trusted computer specification. We are also part of the Confidential Computing Consortium. We are also contributors of Hyperledger Avalon. But more than that, what we actually do is to provide an SDK that really allows you to do off-chain computing using hardware enclave. So this means that you can deploy smart contract on the Ethereum blockchain, and whenever you have computation to do, you can go off-chain, use an enclave wherever on the network, and retrieve the result, and you are sure that you can deploy, you can provision the enclave with secrets. Those secrets will never be revealed. And you have an on-chain attestation that your execution has been executed within an enclave. Okay, that's really important. So to do that, actually, we rely on several T's. The one that you can actually use now is provided by Scone. So Scone is a sort of a spin-off for the University of TU Dresden, Germany. We're also working with Photanix, and we have an ongoing work with Graphene SGX. So Graphene is an open source software for doing computation within enclaves. Okay, so I will now let Hadrien introduce you the rest of this talk.
Thank you. So now that you had an overview of what iExec is, I will go down in the details of how it works, more particularly how we can process private data using SGS T and Intel SGS technologies that Gilles introduced previously. And the thing is, there are a lot of solutions to deal with data today. One of the most interesting ones we use is IPFS, and IPFS is great when you want to store public data available to everybody. But if you want to keep track of data you own, give authorization to some people or remove authorization to use it, IPFS doesn't provide that. So we need to build a layer for data privacy on top of public data layers like IPFS or Swarm or anything. And so basically these are the different steps we'll have to go through to process data privately and securely on iExec. The first point, obviously, is to encrypt your data and publish the encrypted data to a public layer like IPFS. once the data is encrypted, to anyone who don't have the private key to decrypt it, it's just like noise. So there is no issue if this spreads or if you lose control over that, because what you want it is to be available to everybody so that anyone that has the encryption key can decrypt it. And now you have to manage the private key to decrypt the data in a very secure way, which is what we do. The next step is to register your data on chain. So we have a repository, which is a smart contract that stores details about the data. This includes address to the data, checksum, stuff like that. But most particularly, it controls the ownership of the data. And what's interesting in iExec is that any piece of data that is on IPFS is linked to an Ethereum address. And this Ethereum address will be controlling the dataset, which means that even if the encrypted data is public to everybody, there is a record on chain of who controls it and who can give authorization for the usage of this data. And this is important because in the next step, we are going to store the encryption key of your data in what we call the secret management service, the SMS. And so this is a server that will store your encryption key and that will verify that anybody that is asking for a key corresponds to a strict criteria. And this means that the SMS will be linked to the blockchain, and it will verify on-chain that transactions have been made, signature have been performed to use your data. You can trust the SMS because it's running in an enclave, so you can attest what code is running, and you can attest that the rule that it's implementing are the right one. And then the next step is once you've put your encryption key in the SMS, you will define access policies using the iExec dataset order. And the dataset order, I think Gilles discussed that previously when he talked about making a deal and attesting on-chain that people agree on the computation, is your component as a dataset provider saying what you agree to be done with your data. And so you can define access policies like who has access to it, what application can use it, and how much you have to pay for that. And so you can have many number of configurations. For example, you could say, I want anyone to be able to use it in a specific application that won't leak it, and they have to pay that much amount. Or you can say, this is a research institution. I agree for them to use my private data for free, as long as they are doing it for research using a specific application. So that's how you define access control to your data. And then you put your order in the marketplace. So the marketplace is like the front end of iExec. And this is where you will find orders for your dataset, but also for the application and the computing resources. So this is where everybody is giving authorization to their resources, and you just have to find matching authorization to trigger a computation. Obviously, the marketplace is a website we host, so some might say it's centralized, but it doesn't mean the protocol is centralized in any manner, way, shape, or form. It's similar to what 0x protocol is doing with their order. So next step is doing a dedicated peer-to-peer network for orders, and there are already mechanism on iExec where you can send your order to a smart contract and it will emit an event. This we cannot censor, so if you want to make sure anybody can receive your event and you are not censored in any way, shape, or form, you can always do that. It costs a bit of gas, but it's completely decentralized. And so now, how does it work? So this is a bit complex. Maybe it's difficult to see on the screen. I hope we will be able to share the slide with you later on. But this is an overview of the entire iExec infrastructure with Web2 tools like the marketplace that I showed you just before, and the different actors that are the requester, the scheduler or worker pool manager, the dataset provider, and the application provider. And in our case, what we're interested in is the dataset provider, but you imagine that if you want to do an app, the process is pretty similar. And so we have our data that is on IPFS, this is encrypted, and we have the data represented in the blockchain. So this is metadata that we discussed earlier that controls the ownership. And so the iExec dataset owner will not only push his data to IPFS, but also put the secret in the SMS, which is here, which is represented as a small shield because it's running inside an enclave and it's secure. And once you've got your dataset order that describe how the data can be used, it will be matched with application order, which basically are provided by the app developer and say, this application can be used by such person for such price. You've got the worker pool order, which is basically providing access to computing resources, and your request order, which is, I want to run this application with this dataset on this worker pool. And those orders, so those force orders, are sent to your iExec layer, which is a smart contract on the Ethereum mainnet. And this smart contract will verify the compatibility of this order. So pretty similar to the 0x protocol smart contract. The difference is our orders are not symmetrical, but you can imagine it the same way. So it will verify the orders are valid, they have been signed by the right persons. And this is why we need details of who owns what assets on the blockchain. This means that we will verify that a dataset order has not been forged and was in fact signed by the owner of the dataset. And then this triggers a deal that we discussed earlier, and then tasks. And tasks are the unit of execution. And those tasks would be scheduled on different workers, and the workers will run application inside secured enclave. This means that whenever they're processing data or processing the temporary information, everything is secure within the worker. But the worker, to do the computation, he needs access to the data, so he can retrieve the encrypted data from IPFS, but he will also need the encryption key. And for that, it will have to request it from the SMS, and this is where the SMS will have to verify that the request is valid, because there is a task that has been recorded on the blockchain, that payment is valid, and that the enclave that is running inside the worker is the right application. This guarantees that your data will not leak and will only be executed depending on the authorization scheme you defined previously in your orders. So I guess this is pretty complex. We've got extensive documentation online, and we have a booth here. So if you get lost, don't hesitate to ask us. Also, we have many tutorials, and we would like to present a few use cases that you might want to develop during this hackathon. So one of the use cases is the trusted oracle one. And basically, this goes far beyond just computation. It's using the iExec layer as an interoperability layer. You will be able to perform computation in a worker that is secure through the SGX and using our consensus protocol. And this execution will be able to process secure data or fetch data from the Web 2.0. And this T is interesting for many things. First, you could access data from secured APIs using datasets for storing your API keys. You could also use that to do some random generation inside an enclave and send the result back to the blockchain. So what we want to do is build a completely decentralized layer for execution and trusted layer for execution of chain. Whatever you do with Web 2 should be the only single point of failure. What we want to be sure is we can attest Web 2 data and send it back to the blockchain. Obviously, Web 2 data is still centralized, so this is potentially an issue, but as you can build your application the way you want, you could do aggregation inside SGX. You can combine multiple sources, which is quite interesting. Something like things that Maker does in the smart contract, you can do it off-chain in a secure environment and just bring back the result. You have less processing to be done on-chain. So we've got an example for that. We've got the iExec price feed. We are querying a few API keys. I don't know if you can say that earlier, but for you, you will have a scoop right now. We are working with Keiko provider to get data, and if you want to learn more about our partnership with them, we will announce more at ETHCC in just a few weeks. So feel free to come if you come back to France. Code for that obviously is available, so you can use it as an example to bin your old Oracle using the iExec solution. Another use case is end-to-end encrypted data with healthcare application. So this is more prospective, but it's just to give you ideas so you can be creative during the hackathon. We can preserve the secrecy of data from the requester. So a proof of concept we are actually working on, and we presented at RSA conference, is how persons can provide access to their personal medical data to do research or to find some illness without leaking too much about what they do. And this could be interesting because you can, for example, keep your private data for yourself and just have a claim for an insurance using an application that will process your data and give you a score but not leak it. It could be interesting for any kind of application. I think we have also a recent article with Chainlink on how we can do as exec to do insurance for cars and stuff like that using our processing of chains. For private data. So conclusion, you should definitely try it out, build with it today. We've got many prices. So first, second, and third price are just for integration of the iExec stack in your hack. So that's pretty open. And we have some bonuses. We are working with IPFS for data storage. So if you are creative with your IPFS usage, you can win an additional 500 DAI in top of a price. Also, we are working with the graph to give access to the iExec data, because it's not only smart contract, it's more than that. If you want to query whatever happens easily, and we use the graph stack for that. So the graph is public, obviously. If you don't know them, you should definitely check them out. And if you're using the iExec subgraph in your hack, you can win an additional 500 DAI. So for the most creative among you can target first prize plus the 2 bonus prize. It would be a very large hack. But anyway, even if you're not targeting those prices, iExec stack is here for you to use. It's very interesting, and you can use it beyond the hackathon for your project. So here are some pointers that could be useful to you, more particularly the documentation. It has been refreshed pretty recently. You should have a lot of details about how to build an enclave-empowered application. And you've got tutorials about how to build an app, how to build an app with a dataset. And obviously, you can ask us at the booth if you have any questions. Thank you, and we have some time for questions, I guess. Yes? So the SMS is completely off-chain, but the SMS is connected to the blockchain, so it's able to know details about ownership of different assets. I'm not sure I clearly answered the question, but as an application developer or dataset developer, when you want to put a dataset, you put the encrypted dataset on IPFS, and you go to the SMS telling it, hey, this is the encryption key for this particular dataset. And what you are going to point to is the on-chain representation, which is the metadata. And this contains ownership of the dataset. So you will have to ask to inject a secret in the SMS, and you will need to sign this request using your private key. That way the SMS can verify that you are the rightful owner of the dataset, and you are legitimate to push a secret in the SMS. And when you do that, basically you are giving away your key to the SMS, so you are accepting the rules that are encoded in the SMS, that the key will only get out of the SMS if the right structure is written on chain. So, and for that you will have to check the smart contract, and the smart contract will only write the structure if you gave an order for that. So the tasks are that we run on our workers are Docker images. So you could use any language you want, Dockerize the application, and put it on iExec. There is a limitation to that, so if you can use any language you want if you are using the regular use without SGX. If you want to put your application inside an SGX enclave, then you will need the correct runtime. And for now, we provide runtime for Python for sure, and JavaScript should be out, if not today, pretty soon. Then we are targeting other languages, like Java, for example. But this depends on us having access to Docker images with the right tooling to put in Enclave. And this is where our partnership with Scone gets involved. We are not the one designing the layer images. We are just taking layer images from Scone and showing how you can build on top of them. So for now, I would recommend Python. But if you don't want the security of trusted execution environment, you just want to use attestations through replication using the POCOs, and you can use any language you want as soon as you can. You just have to Dockerize your image. And this is something that we are really interested in. We want you to be able to take any application that is out there, for example, Blender or Lightroom, any application that exists and is executable. As soon as you can Dockerize it, then you can port it to iExec. We want it to be very easy for you it's really an interoperability layer between the blockchain on one side and any application that runs on any x86 64 processor on the other end. So the first element is that it's an open market. So as a requester, if you want to run an application, you will have to pay the price that the application provider requires you to do. And you will also have to pay extra for the dataset and the computing resources. Computing resources, it's whoever owns them, they set a price to that. So it's an open market. As Gilles often said, it's like an oil market, but instead of oil, it's computing power, which is oil of the Web 3.0. So it depends on whatever resources are available. Then there is the issue that you state that some application will run very fast and some application will be slower. So our market is divided in certain categories, and categories divide like an envelope of what you could do. Its smallest is like 1 minute with just a few megabytes input-outputs, and the largest one is several hours of computation. So obviously this is a model that could get refined, but this is a vision. It's very complex because if you allow people to select exactly what they want, then you will divide the market into very different heterogeneous chunks, and it's very difficult to see competition. The fact that we have a certain number of categories help us like regroup provider under the certain categories and have a free market so that they fight to give you the best price. Okay, so I think it's done. We don't have any more time, but feel free to go by the booth and ask us more questions if you have.